Okay, we now move into multiplication and division. So we're going to look at diverse algorithms that we could use when teaching students how to multiply and divide. So when looking at the beginning, we think of standard multiplication algorithm is kind of the first thing that we introduce to students when we want to show them multi-digit multiplication, like those examples below, right? But again, we want to stress, right, the importance of conceptual understanding, right? So without that, that leads to errors and students making obvious mistakes to you, but not to them because of misalignment of place values, right? So without the meaning behind the steps, students often struggle, right, or even know how to check their answer. So let's go ahead and take a look at some things for multiplication. So one of the first things in this example is repeated addition, right? Some form of that. That if we know that multiplication is repeated addition, then we can solve these problems um, in alternative ways. So, for example, 23 times 13 can be thought of as 23, 13, 13 times, right? So what that means is I need to do 23 times 10 and then 23 times 3. And so that's where you would get the 2300 plus 69. And then there's your total. Again, thinking of it in that way, when we think of it that way, this ends up being what we call our distributive property rule, which again, we'll talk more about, but also from past, we've talked about distributive property. How about 14? That's 14 times 14, right? So it's 14 times. So it's a way to think about it. So that's 14 plus 14, right? Or 23 plus 23, 13 times. Those types of things we can think about. So then that allows us to break it up into that way or any other configuration that allows us to multiply, get an answer. So I want you to think about one is through repeated addition. That's what multiplication is. And so we could do it that way. And that connects to distributive property, which we have talked about, distributive, which we then also connect later on as students move on to algebra, right? It's a popular um, property we use to simplify algebraic expressions and solve equations. Another method is duplication, or what is better known as the Egyptian multiplication. Duplication, because you're duplicating. That's the way I think about it. Duplation, sorry, not duplication, duplation. Right? But I think about it as duplication and the idea that we're duplicating by two. So when we think about it, let me go ahead and show you the textbook again as we think about it. In the textbook, we do have a link. Our favorite math educator is showing us how to think through this. And so you have that link, and you will see, again, a little bit more explanation in the textbook. But looking at this is 26 times 17. I can't do that in my head, but you actually can if you just know your doubles, right? It's the double technique of adding, kind of doubles. Students know doubles. So I know 1 times 17. So then if I know 1 times 17, I know 2. If I know 2, I know 4. If I know 4, I could figure out 8. And if I figure out 8, I could probably figure out 16. 272, right? So with that in mind, if I know that, I can then just I need 26 17 times. So then what that means is then I just going to use that one and that one. So then, oh, what do I need? Sorry, 26. Oh, let's redo that. I need 17 26 times. So that's where I would get the 16, 18, and then the 2. And let me delete that real quick. There we go. And so then that's where we get this sum here. So then we can just add up 34, 136, 270. It's just another way to think about it. And you hadn't thought about it before. So here's another example here of the Egyptian multiplication method. 13 times 29. So 13 times 29. And so you could see if I know 1 times 29, I know the remaining. I need 13 29. So I have 8 here, I have 4 here, and 1 here. And so then you add those up and you get 377. Just another way to think about it. Not going to say it's going to replace, but it's this idea back to mathematical mindsets that mathematics makes sense, right? Things are connected. It can be creative. There are multiple ways to solve problems and not just one way. Another method that you may find useful is what we call the lattice method. And we've had that term for addition, so it's very similar. The lattice method for multiplication. And so let's complete one here for this example before we jump into the standard algorithm, what we know, and intermediate algorithm. So we're doing 63 times 57. We're not using the standard algorithm. We're using lattice. So you create boxes like this. You see, it'd be a 2 by 2, and then you have the diagonal similar to the addition. Then you do 3 times 5 is 15. 3 times 7 is 21. 6 times 5 is 30. 6 times 7 is 42. What I want you to see is that this is, again, right, single digit multiplication. And then we add diagonally. So 1, 5 plus 2 is 7 plus 2 is 9. 1 plus 0 plus 4 is 5, and 3. So now I know the answer to this problem is 3,591. Let's go ahead and try another one. Let me change colors. Let's go with red. So notice I have the box, 3-digit, 2-digit. So you have 3 by 2, and then you put your diagonals in. And then you just do the multiplication, single digit 2 times. So this is pretty straightforward. It's an algorithm. It's a different algorithm, a lattice method. And so then we have that. And then you add diagonally. Notice what I have. 3 plus 2 is 5, plus 5 is 10. And I could put the 1 here or over here because I have an extra 1 to put in there. I'll put it on top since it's kind of like our standard algorithm. 4, 8, 9, 2. So now I know my answer to this is 29,070. It's that easy. That's it. Now, if you were going to do, in this case, 58 times 67, you would create a 2 by 2 box like this, and then diagonals just like that. I'm going to have to write over that. There's your 58, 67. You get, again, we need to know our single digit. 56, 30, 35. So there's your 6. 13 plus 5 is 18. I need a little 1. 5 plus 3 is 8, and then 3. So now I know the answer is 3,886. So that's the lattice method.